Okay, anybody else has any question?
Raphael's comment was pretty accurate with understanding the general shape
Okay.
of x over x plus n, because we understand like the general domain. So could we use that in the future instead?
Let me see. Could we also utilize the fact that there is a vertical asymptote at x equals -1? Yes. And because if the value is not in the domain, it creates vertical asymptotes. Then, so the n behavior, right, at x equals, let me see the limit, and the general shape of x over x plus n, where n is an integer, and assume that the left limit is positive infinity, and the right limit is negative infinity. You mean at x equals to n, right? Yeah, make sure, right, Raphael's is comment is right, but just make sure it's for the point x equals to n. All right, yes, yes, you could think that way. Okay, questions come. Hello, anybody has any question?
I have one question.
Go ahead.
For let's just say for any graph in general, like if you go back to number 4 quickly, it only tells you -2 to 6, like the domain. You're only seeing a portion of like the entire graph. So let's say if you
Oh,
extend it to
we just
negative
assume
infinity,
this going to,
positive infinity.
I see your point. We just assume this going to, let me mark here.
For example, let's say if we extend x past 6, the value, and
Just
-2, you go
imagine
0.3.
this.
Yes.
This is going on forever to be continuous. This is going on forever to be continuous.
So
If they do ask that kind of question. All right. Usually, usually they have to give you more information. But if just like this, we just assume this way.
oh, okay.
Okay. Okay. Any other questions? Yeah, for number 11, the answer is 2 over 3. For both. That's no, right. If you try to evaluate, right, that's about 2 over 3. But because we simplify this to be x over x plus 1, we can get exact answer. That's 2 over 3. Any other questions? All right. Let's keep going. Okay, let's look at number 15. So that's another method I did not talk about last time. So this one, we want to find the limit when x equals 0. And of course, 0 is not in the domain of 15. Okay, I'm talking about number 15. X is not in the domain of this function. So what can we do? We can multiply by its conjugate. So we want to use the difference of two square property. So we can multiply, this will be, so we want to multiply square root. So I'm going to use this square root of x plus 4, then minus 2, right? But we want to multiply by its conjugate. Remember, a squared minus b squared equals to a plus b times a minus b. We want to use that property. So we want to multiply by plus 2. Plus 2. And of course, we want to multiply by, we can only multiply by 1. And this one is the square root of x plus 4 plus 2 divided by itself. Right? Divided by itself. I just do da 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 here. So we multiply this one. This one is the square root of x plus 4 plus 2 divided by square root of x plus 4 plus 2. After we do that, so the numerator becomes square of square root of x plus 4, which is just x plus 4, right, minus 4. So x plus 4 minus 2 squared, which is 4, right, which just becomes x. So the numerator becomes x. Then x is simplified with this x, with the denominator x. So the whole thing becomes 1 over. So it becomes 1 over square root of x plus 4 plus 2. Right? So now, if we plug into x into 0, we have no problem. Right? 0 plus 4, still 4. Square root of 4 is 2. 2 plus 2 is 4. So the answer for this is 1 over 4. Okay, let me try one more time. So we know difference of two square property. So let me maybe right here. So many times we use this trick. So we know a squared minus b squared equals to a plus b times a minus b, right? It's called the difference of two squared. So sometimes if a is the square root of something or b is the square root of something, we want to multiply by its conjugate. We call those two conjugation. Because once we do that, we get a squared minus b squared. That's how we get rid of square root sign. So here, a is the square root of x plus 4, b is 2. So we multiply by square root of x plus 4 plus 2. In that case, we get the square root of x plus 4 squared, which is just x plus 4, minus 2 squared, which is a 4. 4 minus 4 is 0. So the numerator we left with x. Then x is simplified with this denominator x. So it becomes 1 over square root of x plus 4 plus 2. Now we have no problem to plug in 0 because 0 is in the domain of this new man-made function. And plug in 0 into x, we get square root of 4, which is 2. 2 plus 2, which is 4. We get a 1 over 4. Any questions?
Just the second
So
step, Professor.
Sorry,
Yeah.
you can go first.
Yeah, go ahead, ask.
Yeah, just the second step. When
Oh,
you
the
go
second
from
step.
yeah, just go over that one more time for me.
Okay, the first step is we multiply by this conjugation a plus b.
Yes.
The second step, we get a squared. We get square root of x plus 4 squared. What's that?
So
Square root of square.
so then you get
X plus
x
4,
plus
right?
4. Yeah.
Right. That's how we get rid of this square root. It's square. So
Okay.
x plus 4. Then minus b squared. B is 2. What's 2 squared?
Oh, okay. Oh, I see. And then that's how you get x plus 4 minus 4. Okay.
That's right. So then x divided by x becomes 1. Okay, any other question? Okay, we can only multiply something by 1. All right, we multiply by square root of x plus 4 plus 2 divided by square root of x plus 4 plus 2. I just do not have enough space, so I write it divided by dot, dot, dot. Dot, dot, dot means the same as the numerator. Okay, we can only multiply by 1. This one is something divided by itself. Okay, any other questions? Right, we simplify to be 1 over square root of x plus 4 plus 2. When we plug into 0, the denominator won't be 0 anymore. Yeah, the denominator is, right, the numerator is 1. The denominator is the square root of x plus 4 plus 2. Yes. X divided by, no, x divided by x. You see the denominator has x. X divided by, because the numerator is simplified to be x plus 4 minus 4, just x itself. So it's x divided by x times square root of x plus 4 plus 2. Then x divided by x is just 1. So it becomes 1 over square root of x plus 4 plus 2. Then we can plug in 0. So 0 plus 4 plus 2. So that's a 1 over 4, right? Okay, any other questions? Okay, let's check out the 17. Anybody has any suggestion for 17? One, obviously, 1 is not in the domain of this function. So what do we do with this? We use something called a binomial theorem. So we factor out the top to be x minus 1 times x raised by 5 plus x raised by 4 plus x raised by 3 plus x raised by 2 plus x plus 1. So this one is, let me write in the front. This is x raised by 6 minus 1. So it can be factored this way. So x raised by 6 minus 1 can be factored as x minus 1. Then x raised by 5 plus x raised by 4 plus x raised by 3 plus x raised by 2 plus x plus 1. You can multiply this out. Then this one simplified to be x raised by 6 minus 1.
Can you put that?
Well, for now, there's too much to talk about. You should have learned this already. Something called the binomial theorem.
Okay.
All right, just remember binomial theorem later on, because that's not in this course. And then x raised by 10 minus 1, you can also simplify to be x minus 1 times x raised by 9 plus x raised by 8, until plus 1. So then x minus 1 divided by x minus 1 simplified. So I left with x raised by 5 plus x raised by 4, so on and so forth, divided by x raised by 9 down to plus 1. Then 1 is in the domain of this new function. So we just plug in, right? The top, how many 1s we have? We have x raised by 5 up to x raised by 0. 1, 2, 3, 4, 5, 6. We have 6 1s. The bottom, we have 10 1s, right? Because we have x raised by 9 down to x raised by 0. Think about 1 as x raised by 0. So we have 10 1s. So this becomes 6 over 4. So no, 6 over 10. Or, so this equals to 6 over 10. I'll simplify that. So divided by 2, 3 over 5. Okay, so right, to find the limits sometimes requires algebra skills. Any question for this? Okay, let's go over 16 again. 16, we want to use one very important identity. So limit when x approaches 0, sine x over x is 1, or sine x over x raised by n equals to 1. Let's just go back to remember the formula. The formula is super important. Okay, here. Right. So limit when x approaches 0, sine x over x equals to 1. And we could extend this one to be this whole thing raised by some case power. Oops. Raised by case power. So sine x raised by k divided by x raised by k equals to 1. Or sine 3x divided by 3x equals to 1. As long as the angle is the same as the denominator. Okay, remember x is just a container, right? Empty container. X can be 3x, can be 5x, can be very long expression. So we use that for this case. In this case, the angle is 3x and 5x. For the numerator, we have tangent 3x, so the angle is 3x. For the denominator, we have tangent 5x, so the angle is 5x. So we want to use the 2 because x approaches 0. If x approaches any other number, we may not be able to use that identity. So what do we do with this? We think about the tangent 3x as sine 3x over cosine 3x. Right, that's tangent. Tangent equals to sine over cosine. We use this property. So sine 3x divided by cosine 3x divided by sine 5x over cosine 5x. We simplify that, we get sine 3x, we get this one. Sine 3x cosine 5x divided by cosine 3x sine 5x. Right, because the numerator tangent 3x is sine 3x divided by cosine 3x. And then we divide it by sine 5x over cosine x. That's same to say multiplying by cosine 5x divided by sine 5x. So cosine 5x becomes the numerator. Sine 5x is the denominator. So we read it out. We have this. Now, how do we use the property of sine x over x when x approaches 0 to be 1? For sine 3x, we need a 3x in the denominator. So we just multiply 3x over 3x, right? Let me use different color. Oops. All right. Let's choose the whole thing. Can I use different color? Okay, so 3x. So multiply by 1 again. This one is 3x divided by 3x, right? And also, x over sine x, when x approaches 0 equals to 1. I also want to multiply 5x over 5x. Maybe I'll put over here, 5x divided by 5x. Right. So I multiply by 2 ones, right? One is 3x over 3x. Another one is 5x over 5x. Then now I want to pair them up. So I have sine 3x here. I have sine 3x here. I have 3x in the denominator. So when I take a limit of this, because this is all under limit x approaches 0, all right? That becomes 1. Then I have sine 5x. I have a 5x in the numerator. So limit of x approaches 0, 5x divided by sine 5x also equals to 1. So all those disappeared. What's left? 3x cosine 5x. 3x cosine 5x left for the numerator. Then cosine 3x, 5x left for the denominator. Then x divided by x becomes 1. So I have 3 left, 3 and 5 left. So the numerator becomes 3 cosine 5x. Denominator becomes 5 cosine 3x. Now I have no problem to plug in 0 because cosine 0 is 1. So I plug in 0, I have 3 cosine 5. Right? Plug in 0, so that becomes 3 cosine 5, because 1 times 5 is 5, divided by, 0, that's 0, cosine 0, what I'm talking about, divided by 5 times cosine 0. Cosine 0, we know that's 1. So cosine 0 is 1, cosine 0 is 1. So the answer is 3 over 5 for 16. Okay, does this make sense? Anybody has any question? Basically use the property of tangent equals sine over cosine, then simplify from there. Then we make sine 3x over 3x. Then also we make a 5x, 5x over sine 5x, because we want to use that property. Okay, if no question, I'm going to go forward. All right. Okay, if limit exists, limit is just a number, right? So the properties for real numbers stays for limits. So this limit of addition of two functions equals the addition of the limit of two functions. Limit, subtractions is subtract of two limits. If a function has a scalar c, this c represents a real number. We can factor out this c. Limit of multiplication of two functions equals to the multiplication of two limits. Limit of quotient is the same thing. It's the quotient of the two limits. All right, this comes from, we can add two real numbers, we can subtract two real numbers, we can multiply, we can divide. Dividing requires the denominator cannot be 0. And also limit of function raised by nth power is the nth power of the limits. This 7 is important. So what's the limit of a number? Limit of a number is just a number because it is independent of x value. Limit of a number is just a number. Okay. think about what's the limit of 3. That's 3. Because it's independent of x value. You come from the left, you come from the right. The constant function is a constant. Think of this as a constant function. Constant function is a continuous function. Right? Every y value is the same. Limit of x approaches a of x. This is identity function, right? F of x equals x. Identity function. Of course, it's just itself. Polynomial function. This is saying polynomial functions like linear functions, quadratic functions, or any degree n polynomial functions. The limit is just the function value. So this property gives any polynomial function the limit at a certain point, just the evaluation of the function at that point. Similarly, for the root, nth root of the function, this is the nth root. Because this we call polynomial-like. It's not a polynomial, but we can write it as x raised by 1 over n, right? So it looks like a polynomial. Same thing for this. If we square root n square root of a function, then take a limit. That's the same as take a limit first, then do the nth root. So let's see this example. This example is for polynomial function, right? We want to find limit at x equals to 5, approaches to 5. Well, 5 is in the domain of this function. If it's in the domain, we just plug in. Right? So for any polynomial functions, the limit just the function value. For polynomial functions, limit of x approaches a number, let's say approaches a, is f of a. Right? So this is a quadratic function. It's a degree 2 polynomial function. The limit of x approaches a, just f of a. So in this case, the limit of this is just f of 5. Right? Just f of 5. How do we get that? We just apply the property from before, right? Limit of the first one, limit of the second one, limit of the constant, limit of 2x squared. 2 is just a number we can factor out. Or limit of x squared to the 5 squared minus 3, limit of x, just limit of just 5. Limit of a constant, limit of a number, just the number. So get 39. So this is just, if we call this function f, we call the function f, so this is f5, f of 5, f being evaluated at 5. Well, let's see b. b is a rational function. Rational function is asking, okay, x approaches to -2. Well, let's try -2. Let's see if -2 is in the domain of this function. Well, -2 times -3, that's positive 6. 5 plus 6, that's 11. No problem. So the limit at -2 is just evaluation of this function because -2 is in the domain. All right, so if we call this function g, if we call this g of x, and the limit just g of -2. Okay, because at that point the function is continuous. If the number of x in the domain, so at that point function is continuous. If it's continuous, it's just evaluation of the function. All right, if you have any questions, stop me anytime. Right, that's this result. If f is polynomial or rational function and a is in the domain, then the limit of the function just the function itself, right? Hold on 1 second. Let's see these two examples. So limit of theta goes to 0 cosine theta, right? This is not a polynomial function, but it's a sine cosine. We know sine cosine continuous, right? Continuous function at any real number. So we just plug in cosine 0. Cosine 0 equals 1, so limit of 1 equals 1. And sine 0 is 0, so limit of 0 is 0. Right, so limit cosine 0 is 1, limit sine 0 is 0. You can also see from the graph. Well, in general, limit of theta approaches a for sin theta, that's sine a. Limit of theta approaches a, cosine theta equals to cosine a. Let's see example 2. So this one we have limit x approaches 1, x squared minus 1 divided by x minus 1. Or we cannot plug in 1, right? 1 minus 1 equals 0. So cause problem, we simplify. Simplify, we get x plus 1. So then we just evaluate at 1. So because 1 is in the domain of this new function, so 1 plus 1 equals 2. Piecewise function, we just deal with piecewise. In this case, we have g of x equals x plus 1. If x not equals 1. If x equals 1, we assign g of x equals to pi. So we want to find when limit approaches 1, right? Because one part, so basically piecewise function divided the domain into 2 parts. So for the first one, the domain is not x not equals to 1. For the second one, x equals to 1. So limit, so we try to find right limit and left limit. So limit of g of x, so limit of 1, x plus 1. Well, this is just a linear function, right? For linear function, it's polynomial. We just plug 1, we get 2. But then but this one is saying when x equals 1, we assign g of 1 to be pi. Of course, 2 is not equal to pi. So what do we do? So this one linear function, but x is not in the domain, so we get this picture. We get this picture. You get this pretty circle on the line. But then because we assigned g of 1 to be pi, so we make a solid dot at the pi value. Pi equals 3.14, so on and so forth. So the function value is here. So we see this function limit at x equals 1 approaches to 2, but not equals to the function value. So that's saying the function is not continuous at x equals to 1. We see example 4. If you have any questions, stop me anytime. Example 4, we have this limit h approaches 0. So 3 plus h squared minus 9 divided by h. And of course, we cannot into 0 into h. So what do we do? Let's define f of h. Define this as a function h. Right? And then we can simplify this a little bit. How do we simplify? We just extend 3 plus h squared. Because we know 3 squared is 9. 9 minus 9 will be 0. So 3 plus h squared is 9 plus 6h plus h squared. 9 is 9 becomes 0. So left with 6h plus h squared. Then divided by h, we can simplify with h. So have 6 plus h. Now we have no problem to plug into 0. Right? 6 plus 0, that's 6. Right? So that's how we find the limit of this one. Well, find the limit of this, we use the conjugation again. Right? T to be 0 is not in the domain of this function. So we multiply by 1. We think about a squared. This is a minus b. We want to multiply plus b. We get a squared minus b squared. So we get this square minus 3 square. So t squared plus 9 minus 9. 9 minus 9 becomes 0. Then t squared simplified with t squared. Right? T squared simplified with t squared becomes 1. So we're left with 1 over square root of t squared plus 9 plus 3. Now it's 0 is in the domain of this function. So we just plug in 0. Plug in 0, we have 0 squared plus 9. That's the square root of 9. And then square root of 9 is 3. So 3 plus 3, 6. We have 1 over 6. Right? We don't have to do this step. This step is kind of confusing. Take the limit, put the limit inside. We don't really have to do that. Okay, so we can leave the limit inside. Plug into 0. So we have 1 over 6, limit of 1 over 6. Limit of number is just a number. So this one equals 1 over 6. Okay, let's look at this question. This question is to show that limit of this function equals 0. So the book is saying we cannot use this. So we know limit of multiplication of two functions is a multiplication of two functions. But the problem is this. For this part, this is a polynomial, right? It just becomes 0. But then we have no idea about the second part, because the second part, 0 is not in the domain. Because in mathematics, we cannot do 0 multiplied by infinity or negative infinity. It's undetermined forms. So what do? We use the squeeze theorem. The squeeze theorem is saying, well, we know sign value is bounded by -1 and 1. Right? Sign value is bounded by this. Then we multiply x squared in every spot. So x squared sine 1 over x is bounded by -x squared with x squared. And then we know limit of x squared when x approaches 0 is 0. And also limit of -x squared when x approaches 0, also 0. So we use this squeeze theorem. So take a limit, right? Take a limit, let me write here. So think, okay, limit of this when x approaches 0. Take a limit in 3 spots. I will put a limit here, put the limit here, put the limit here. All right, I'm only going to put the 1 here. So put a limit over here too. And also put the same notation over here too. So take a limit in 3 spots. And the limit of this one, the lower end, goes to 0. Limit of the top end also goes to 0. So if there's any value in between of 0, it has to be 0. So this is called a squeeze, right? So function less than it, we'll take a limit goes to 0. Function bigger than it, we'll take a limit equals 0. Then the one in the middle is being squeezed to be 0. All right. Again, this identity, right? Try to use this identity. Or let's see this example. Example 10. We try to find limit x approaches 0 sine 7x over 4x. Right? What's missing? The angle is 7x, which is missing 7x. So we just multiply 7 over 7 to make a 7x in the denominator. So we just multiply 7 over 7. Right? Multiply by this 1. Then we regroup. We regroup 7 sine 7x divided by 7x. Then we're left with 7 over 4. So when we take a limit of sine 7x over 7x, that becomes 1. When x approaches 0. Or important when x approaches 0. Then we're left with 7 over 4. Well, limit of a number is just a number. Limit of 7 over 4 when x approaches 0, that's a 7 over 4. Well, let's see 11. We do not have sine theta, right? But 0 is not in the domain of this. So what do? We want to use the identity. Remember the identity sine squared plus cosine squared equals 1. So we want to use sine squared plus cos squared equals to 1. So how to use this identity? We want to multiply by its conjugation again. So we think of cosine theta minus 1 as a minus b. We multiply by a plus b. Then we get a cosine squared minus 1. Right? Cosine squared minus 1 by the identity is just sine squared. So the negative sine squared. Right? Negative sine squared. Then we could form, so this negative sign can factor up front. We can split sine squared into sine squared times sine squared. So we get a sine squared sine theta over theta. Then we have sine theta over the cosine theta plus 1. And sine theta over theta when theta approaches 0 give us 1. Okay, so I have negative 1 here. But for the second part, 0 is in the domain of this function because cosine 0 is 1. 1 plus 1 is 2. But sine 0 is 0. So negative 1 times 0, this is 0. All right, so this one we use the identity. All right, any questions? Okay, if no questions, let's do some exercise. Okay, let's just choose from here. Let's try some even numbers. All right. Let's try 12, 16, 18, 22, 24, 26, 28. All right, let's try this bunch. Yes, ask questions. Yeah, if you have a question, please ask a question. Please speak up. Anyone has any question? Anytime you have questions, just speak up, okay? Okay, so next class, we'll start to present those questions. You can also do 14 and 20. Today we won't be able to have time to review this, but next class we'll start with those questions.
Hey, can you repeat that one last time?
I'm sorry?
Can you repeat that one last time?
Oh, I said next class. Let me type in the chat also. So next class we will start with these questions as review. With question 12 up to 26. All right. We don't have time today anymore, so okay. Before we finish, anybody has any question?
Miss?
All right. Okay. So thank you then. Thank you. I see you next class. Sometime. Okay.
Wait,
make
sorry.
sure you. Right. I'm happy. Monday I went online. I realized no one was in classroom. I realized there's no school. Okay.
No, we had class this Monday. We were all
We do.
waiting.
I was talking about the past Monday. I didn't realize
Oh.
that. So then afterwards, I wrote down my calendar. So
Yeah,
let's all follow that.
It's this coming Monday, yeah.
Yeah. Okay. Thank you.
Just for
Anybody has any
clarification.
question?
Oh
Just for
wait, so we don't
clarification,
have class Monday? Is that what you're saying?
No.
Like Labor Day?
We didn't have on Monday.
Oh, okay.
we did have class the past Monday.
Yeah, the past Monday we did not have.
No,
I
the
mean,
past
The
Monday
past
we
Monday
did
we
have.
did have.
No,
no,
I
I
mean,
mean, do you teach on holidays? That's what I'm asking.
no, we just follow the school calendar.
Okay.
We follow
you.
the CUNY calendar.
So, Professor,
Yeah.
so this Monday will be Labor's Day, right?
This Monday is normal class, right?
Yeah, no.
Yeah.
This Monday is Labor Day. This coming Monday is Labor Day.
Oh, okay. So this coming Monday, no class?
Yeah,
Okay.
it was
And
last Monday.
we were
Last
here
Monday we did
last
have class.
Monday.
I'm sorry, I'm kind of confused. Okay, let's all follow the CUNY calendar.
Yeah, Professor, I think you mixed up the Mondays. Last Monday this past Monday we did have class.
But no one was in the classroom.
We were though.
We were all waiting.
What? I'm sorry?
Everybody
We
was
were
here.
all waiting in class.
Really?
Yes.
Some of us stayed
Yeah,
for like an hour
really?
and something.
Yeah, I stayed for like
Oh,
an
I'm
hour.
so sorry. I was in the wrong classroom? Oh,
Yeah,
I'm so
'cause
sorry. That's my fault.
You
Or probably I
probably
entered
messed
the
up
wrong
the
classroom.
calendar.
I was waiting too. I was like, oh, then there may be no class.
No, I think you were in the wrong classroom because we were here.
Oh my goodness, I'm so sorry. Oh, I can't believe that. Oh, so sorry. I apologize. My goodness.
Professor,
Yeah.
when will your office hours be regarding the Lumen Learning, the exercises that you put up?
This semester, the office hour is tough. The office hour is supposed to be after 11, but however, I have to teach at the government. So I talked to the lab. So have you ever been in the what do you call it? Dorsey Annie Center, Learning Center?
Sorry, can you, what was the question?
Something called the Dorsey Annie Center, Learning Center.
No, usually for my other classes, when they have office hours, it's usually like before or after class, like 10 minutes before or 10 minutes after.
Right. It's supposed for me as well. But however, the problem is this. The problem is I have to teach. I don't know if you know this school called Garment Community College.
Mm-hmm.
Right. I have to teach. Oh, actually, in between, I do have half hour. Right. You can always ask me any questions after 11 o'clock. Or you can ask me questions now because I have a couple of minutes. My next class.
I'm just asking for future reference because I started doing the exercises and like I noticed that I noticed
for
that.
that kind of question, I posted on the. Let me show you. You should ask the help from the tutors. Oh, can I go there?
Oh, no, it's not a question about calculation. It was just like about, so I noticed when I like read one of the questions wrong, and then it didn't let me put in a new question. It didn't let me put in a new answer after like I think 1 or 2 tries.
You know what? For that kind of question, you could ask me, but I do not have answers. You know what? I have to find out for you. I have to ask someone else. I have to ask for the coordinator. You can send me the email to state your question, then I'll forward to him. Because
Okay.
for this course, I have a coordinator.
Okay, good, because I emailed like last time, but I don't think that you got it. So if I have a problem this time around, I'm just gonna forward the last email and like any future questions I have
That's
regarding
right.
like, the
That's right.
technical.
I'm gonna forward. Right. I'm gonna forward your question to look for answers. Because I don't know how the setup works. Yeah, but email me your questions, okay? We'll try to find answers.
Okay, great. Because I didn't know if the professors as moderators for Lumen Learning have like the ability to refresh a question for a student so they can put in the correct answer.
Oh, you know what? From my previous experience, sometimes the program has typos. Even you have a right answer, the system will still mark you wrong. But if you believe your question is right, because you can always show me the question in class.
Okay. Okay.
All right, so we can talk about it. Because sometimes maybe you did it right, but system somehow have typos, have bugs.
Okay,
You know,
I'll just
you
double
understand what I
check
mean?
for next time. Yeah, I understand.
Okay, you can always ask me questions in class time. All right, you can tell me if the professor have a question with this homework, then show us the homework, so can talk in class. Because sometimes the question may not be your own problem; it might be some other student's problem also. It's good to talk about it in class.
Okay, I'll be prepared for next time. Thank you.
Okay, thank you. Okay, anybody else has any question? All right, see you next class. You too.